The climate crisis is driven by our heavy reliance on fossil fuels, and as a society, we lean on that source of energy for many parts of our lives: transportation, power generation, manufacturing, and heating the houses we live in. Residential homes specifically account for a large portion of the world's energy consumption and greenhouse gas emissions, and conventional house design is partly to blame. In this project, we focused on aspects of designing a Montreal house to be more energy efficient. Our project was inspired by Leadership in Energy and Environmental Design, or LEED for short, a certification and framework for efficiency in clean homes. Our model home was based on an average-sized house of 2,153 square feet, and we've added 6 key features that make the home more energy efficient and environmentally friendly: a geothermal heating and cooling system, aerogel insulation, low-flow appliances, responsive drip irrigation, orientation with respect to the sun, and access to public transit. In Quebec, the Earth's temperature below the surface is about 10 degrees Celsius. We can take advantage of this natural heat by heating our homes using geothermal energy. For our design, we decided to implement a patent by Water Furnace International Incorporated, which uses geothermal energy for heating the home in the winter and cooling it in the summer. In the winter, the working fluid absorbs the energy from warmer ground, and during the summertime, it deposits the heat from the home into the earth and gets cooled. This type of geothermal system installation for our house with a typical 5-ton system would cost around $25,000. It can reduce energy consumption by up to 70%, saving on cooling and heating costs, and this system reduces greenhouse gas emissions, lowers carbon footprint, and will over time pay off the initial investment in savings. Montreal has cold winters and warm summers, so insulation is key if we want to reduce heat transfer and energy usage. Studies show that a well-insulated building could drop energy consumption by 64%. We decided on aerogel insulating. Compared to conventional fiberglass, aerogel provides about 40 times more insulation. For our house, aerogel could cost around $4,000 for the initial installation. However, it has a lifespan of 40 years, which is almost double the time of traditional fiberglass. In the span of 10 years, our aerogel insulation could reduce energy usage by 60%. Low-flow appliances use a smaller amount of water, reducing freshwater consumption and energy used for heating it. Appliances certified with Energy Star can reduce water usage in homes up to 30%. Now, homes have many appliances. Here are average Energy Star costs that we found. It comes out to a total from $7,800 to $15,800. However, Montreal offers rebates for Energy Star certified appliances. Additionally, throughout their lifespan, they can save from $3,000 to $9,000 in water and energy usage. For our home with a lawn and small garden, we switched to a type of irrigation that delivers water directly to the soil of the plants slowly and consistently. Responsive drip irrigation has developed a patent for Grow Stream technology, a drip irrigation system that self-regulates water intake. When plants release exudates from their roots, it signals the micropores in the grow tube to open and supply water. For a 5,000 square foot lot with a small garden, the installation of a responsive drip irrigation system ranges from $310 to $689. It reduces water use by 30 to 50% compared to standard drip irrigation and reduces energy requirements by 40 to 90%. To reduce energy consumption from heating or cooling, our house should be oriented to receive lots of sunlight in the winter and be shaded in the summertime. If the widest surface of the house faces south, we maximize winter sun exposure and minimize summer sun. Additionally, planting deciduous trees south of the house allows for more shade in summertime, and when the leaves fall in the winter, they'll let the sun into the home. If we're constructing the home, we can incorporate orientation into the design, which may increase construction costs by 5 to 10%, but can result in significant long-term savings on heating and cooling expenses. Personal vehicles like cars emit 62% more greenhouse gases than transit by rail, such as the Montreal Metro, so our ideal house should be within comfortable walking distance of a public transit stop. This is around 8 minutes in urban areas and 10 minutes in suburban areas. But homes close to public transit and city centers can be higher in demand and cost more than homes in suburban areas. While these adjustments are environmentally friendly and energy efficient, they are costly. Quebec offers rebates and tax incentives on switching to these options, but it's still a challenge, especially for lower-income households. Another challenge is that homeowners must get permits for projects that modify the structure or purpose of the building, and installation of geothermal systems requires either deep or long horizontal drilling, which can disturb soil composition and local ecosystems. To implement our solution, a site analysis must be done to determine the placement of the geothermal system and orientation of the house. After that foundation, the installation of appliances, drip irrigation system, and insulation would lead this house toward a greener design. As this technology becomes more economically viable and efficient, the switch is easier to make. Community incentive programs may help overcome socioeconomic barriers and encourage a wider spread of our energy-efficient design.